Hi, this is Jeff Spence, your Math 135 instructor from the Community College of Denver. I'm going to do a short presentation on 6.1 and what we went over in the classwork and what's probability distributions are about. So 6.1 is titled Discrete Probability Distributions. One of the key things is that we're dealing with random variables that are discrete, and discrete means countable. Okay, so keep that in mind. And the random variables are, they can end up being any number. That's what makes it random until you go out and observe it. Okay, so I'm giving you a probability distribution here. One of the main things you need to remember in any probability distribution is that all probabilities, all these probabilities here, have to be between 0 and 1. So the probability of any of those x's has to be between 0 and 1. And then the other main rule that you need to remember from probability is that the sum of all the probabilities equals 1. Now, the way that this table rounded it was 0.9999, but that's close enough. It's basically 1. It's just because of a little bit of rounding error. So that's the key ideas of probability that we have to remember for this section and every section going forward. What we did earlier was we talked about an example with from the test question where we found whether or not we asked 4 students whether or not they thought he was funny, and here are the possible outcomes. So, before you do the survey, you don't know if you're going to get 0 people saying yes, 1 person saying yes, 2 people saying yes, 3 people saying yes, or all 4 saying yes. So this is a discrete random variable, and we have the probability of each outcome listed below. I'm going to explain kind of those probabilities in a different presentation, the next presentation on 6.2. But let's just accept that these are the probabilities. Basically what we learned in 6.1 was how to do the mean and the standard deviation of this. And remember, the mean is also called the expected value. So mean is sometimes called expected value. Keep that in mind. An expected value is a long run expected outcome. So the long-term average, if you will, not from one trial of an experiment. Okay, now remember, we learned how to do the mean by taking each outcome and multiplying it times its probability, then adding them all up. So we did, the mean is 0 times 0.4521 plus 1 times 0.3970 plus 2 times 0.1307, and go on and so on and so forth until you have multiplied all the probabilities with their outcomes and then added them all up. The standard deviation we learned to do in the calculator, and I just want to remind you, when you do this, you want to put all your all your outcomes in list 1. And then all your probabilities in list 2, I'm putting those below the list. Then we go over to stat and do 1 var stat, 1 var stat, and we have to remember to enter in L1, comma, L2. And to enter L1 and L2, you press the second 1, second 2, and remember the comma button is directly above the number 7. Okay, so that will give you the mean, which shows up as x bar, and the standard deviation, which shows up as sigma x. Standard deviation of a distribution and the mean. And remember, the mean is the expected value, the long-term outcome, if you were to run this experiment many, many times. So that's basically what we covered in 6.1. I'm going to give a longer presentation on 6.2, so take a look at that, and I'll explain how these probabilities came up in this table.